In this video, we're going to talk about the arithmetic progression. So let's say we have a set of numbers 1, 2, 3, 4, 5, and then on to n. So if you notice, there's a consistent pattern in these numbers. So from the first number to the second number, there is a difference of 1. So if you first subtract, the difference is 1. If you subtract the second number, third number, the difference is 1. Third number from the fourth number, difference is 1, and so on. So if you notice, for each successive numbers that we have, the difference between the net two numbers is 1. Okay? So that's what makes this set of numbers an arithmetic progression. Okay? So this set of numbers can be seen as an arithmetic progression. But let's say you have a set of numbers 1, 1, 2, 3, or something like this. The difference between these two numbers is 0. The difference between this one is 1. The difference between this one is 1. So if you notice, the difference is not consistent. So this is not an arithmetic progression. Okay? Now, speaking about difference, there are two very, very important factors or terms you need to know when talking about arithmetic progression. The first is the first term. The first term is often denoted by the letter A. Okay, so the first term in this set of sequence is 1. Okay, so for this arithmetic progression, we can say the first term A is equal to 1. And then the common difference. Common difference is often denoted by the letter D. So the common difference for this case is 1. So if you know these two values of an arithmetic progression, you should be able to get any term in arithmetic progression. Okay, so to get any term, the nth term is simply given by the formula a plus open bracket n minus 1 d. Okay, so if I'm looking for the third term of this series, and I know that the first term is 1 and the common difference is 1, I'd simply be saying my third term is equal to the first term is 1 plus, I'm looking for my third term, so n is 3. So this is 3 minus 1, and then my common difference from this series is 1, right? So this becomes 1 plus 3 minus 1 is 2 times 1 is 2. So this is 1 plus 2 is 3. So if you notice, the third term here, 1, 2, 3, is still 3. Right? So to get the nth term of an arithmetic progression, you need to know this formula. So what if we decide to add up the values here? So I'll be saying 1 plus 2 plus 3 plus 4 plus 5. And then this 2 plus n. So when we start adding up the values of an arithmetic progression, we can call it an arithmetic series. If we want to know the sum of an arithmetic series up to a certain point, from here to here, I want to know the value of the sums. Okay, there's a formula for doing that. So the sum of n terms on an arithmetic series is Sn, denoted by Sn, which is equal to n over 2, open bracket 2a, plus open bracket n minus 1 d. So to find the sum up to a certain point, this is the formula that you need to use. Okay, so let's say we wanted to find the sum for the third point on our arithmetic series here. We could simply just say Sn is equal to third point. This is 3 over 2, open bracket. Our first term is 1, so this is 2 open bracket 1 plus third term is 3 minus 1, and then the common difference is 1, so that the sum is 3 divided by 2 is 1.5, open bracket 2 times 1 is 2 plus 3 minus 1 is 2 times 1, which is still 2. So we have 1.5 So we have Sn is equal to 1.5 times 4, right? So this is ultimately equal to 6. So if you still come and check here, 1 plus 2 is 3, and then plus 3 is that 6. Let's go into some examples and solve more problems concerning arithmetic progression. Looking at some basic examples on arithmetic progression. So for part A, for question A, we are told to write down the first 5 terms of the AP, with the first term 8 and common difference of 7. So we have our A value to be 8 and we have our common difference to be 7. Okay, so we already know that our A value for our AP is 8, and then to get our next term we need to add the common difference. So 8 plus 7, 15, and then for the next term we still need to add common difference. So 15 plus 7, 22, and then for the next term we say 22 plus 7, which is 29, and then for the next term we say 29 plus 7, which is 36. So our AP is simply equal to, for the first 5 terms, is simply equal to 8, 15, 29, 22, 29, 36. For the next example, I'd like you to pause the video and try to solve this one yourself. So like we did with the first one, our A value is 2 and our common difference is minus 5. So we write our first term as 2, and then for our next term we add minus 5 onto the first term. So this will be basically saying 2 plus minus 5. So one of the things I want you to notice is that when you have 2 plus minus 5, it becomes 2 minus 5. Okay, so this is basically 2 minus 5, and then 2 minus 5 is minus 3, and then the same thing again, minus 5. So minus 3 minus 5 is minus 8, and then same thing again, minus 5. Minus 8 minus 5 is minus 13, same thing again, minus 5. So minus 13 minus 5 is minus 18. So we've gotten our 5 numbers. So our AP is simply 2, minus 3, minus 8, minus 13, minus 18. So for the last example, you're asked to find the common difference of the AP. If the AP is giving us this, so the AP is giving us 11, minus 1, minus 13, minus 25. So to find the common difference, we simply have to do this minus this, or this minus this, or this minus this. So the common difference can be given as second term minus first term, or third term minus second term. Basically the one after a number minus the number. So the common difference is giving us minus 1 here, minus 11. Okay, so minus 1 minus 11 is equal to minus 12. So let's get to another set of problems. So for question D, let's write out the parameters that we know. So we have a sequence of 1, 3, 5, 7, 9. So our first term is 1. Our common difference is simply, we can take that from saying 3 minus 1. So 3 minus 1. 3 minus 1 is 2. And then to find the sum of the first 50 terms of the sequence, we need to use, so our n value, the value that we are looking for, n is equal to 50. So we can simply say S of 50 is equal to 50 divided by 2, open bracket, 2. Our A value is 1. So substituting that, we have 2 times 1 plus, open bracket, 50 minus 1, close bracket. And then D value is 2. S of 50 is equal to 50 divided by 2 is 25, and then open bracket, 2 times 1 is 2 plus 50 minus 1 is 49 times 2, we have 98. So we have 2 plus 98, and then this S of 50 is equal to 25, open bracket, 100. So 25 times 100 is equal to 2,500. So S of 50 is equal to 2,500. So let's take the second question. So for the second question, we are asked to find the 10th term of an AP, the same AP basically. So we have 1, 3, 5, 7, 9. So the first term of this AP, A, is equal to 1. Our common difference, like before, is equal to 2. So we are looking for the 10th term, so N is equal to 10. To find the 10th term, we use this formula. Nth term is equal to A plus, open bracket, N minus 1D. Okay, so the 10th term is equal to, the first term is 1 plus the N value is 10 minus the 1, and then D value is 2. So we have 1 plus 10 minus 1 is 9 times 2. So this is equal to 1 plus 18. 1 plus 18 is equal to 19. So the 10th term of this arithmetic progression is 19. So if you liked the video, leave a thumbs up, share with your friends, and subscribe to the channel. Thanks for watching.